Let's talk about how microphones work. A microphone is a device that changes sound from one form to another. In this specific case, we're changing mechanical energy in the form of sound waves into electrical energy. A device which does that is called a transducer. So a microphone is a form of transducer. There are several different transducers that are used as microphones, but there are only 3 that are common for what we do in video and film production. Those 3 are the dynamic microphone, the ribbon microphone, and the condenser microphone. So let's take a look at each of these. The dynamic microphone and the ribbon microphone both work by generating electricity. They work the same way that a generator works, in that they have moving wires in a magnetic field. This creates electricity. Other microphones require electricity in order to operate, such as the condenser microphone. You have to put energy into it to get a signal back out. So look at this diagram of a dynamic microphone. They work by having a flexible diaphragm which is attached to a coil of wire. And that coil of wire is suspended within a magnetic field. As sound waves hit that flexible diaphragm, it moves back and forth. And by moving back and forth, it's shaking that coil of wire inside the magnetic field. Moving the coil of wire inside the magnetic field creates electric current. So this microphone is actually generating tiny amounts of electricity in response to the vibrations of the sound waves hitting it. And forgive my clumsy animation, there's a limit to what you can do with Google Slides. Dynamic microphones are very common, and there are good reasons for that. They are extremely rugged. Of all the types of microphones that we work with, dynamic microphones are the most physically durable. They tend to be the cheapest as well. They're very affordable. In this world, affordable is a relative term, but you can get a really good quality dynamic microphone for under $200. And they do not require any power. Again, the dynamic microphone works by generating its own power. There are trade-offs, of course. So the cons to a dynamic microphone is they tend to be large. It's very difficult to make a small dynamic microphone just because of the components that go into it. They're not particularly good with high-frequency sounds. That diaphragm and coil of wire have mass and they have inertia, which means it's kind of hard for them to wiggle at very high speeds, so high-pitched sounds do not get rendered accurately. And they're relatively quiet. The output levels from them tend to be low compared to other microphones. So you end up having to turn the gain up a little bit higher in order to get a good sound recording out of them. Dynamic microphones are very good for vocals. They work great in that 1 to 4 kilohertz range where most of the voice is found. And they're also very good for loud things. If you're going to mic a drum kit, a dynamic mic is a fantastic choice for that. The ribbon mic also works by generating electricity. What the ribbon mic does is it kind of combines elements of the dynamic mic. It takes that flexible diaphragm and that coil of wire that moves, and it replaces it with a ribbon of very thin metal. So the ribbon itself wiggles in response to sound waves, and that generates electricity as it wiggles inside a magnetic field. Ribbon microphones are known for excellent sound. A quality ribbon microphone is just a pleasure to listen to. They do a fantastic job reproducing sounds from the very low end to the very high end and everything in between. They have a very flat frequency response. And again, they generate their own power. They don't require any external power in order to operate. However, ribbon microphones are extremely fragile. It is so easy to break a ribbon microphone. Even a puff of air is enough to destroy the ribbon on a ribbon microphone. So you have to be really careful working with these things. Not only are they terribly fragile, they are ridiculously expensive. A high-end ribbon microphone can set you back several $1,000s. They're large, like dynamic microphones. It takes a lot of space, relatively speaking, to manufacture the components inside of it. And they also have very low output levels, even lower than dynamic microphones. You get very little signal out of a ribbon microphone, so you really have to be able to amplify it, which means you have to be in a quiet area to keep that signal-to-noise ratio that you're so interested in. They are best used for vocals. If you're a recording artist and you ever go into a studio, you are probably going to be singing into a ribbon microphone. They work well for most instruments, with the caveat you want to keep them away from loud instruments. Again, a loud noise can damage or even destroy the ribbon inside the ribbon microphone, so keep them away from the saxophones. But you can put them near the string basses or the violins or anything of that nature, and they will do a fantastic job. The other commonly used one in this field is a condenser microphone. Now, a condenser microphone is different in that you have to supply electricity to it in order for it to work. What it has, as you can see in the drawing here, is a flexible metal diaphragm that's very close to a parallel and identical backplate. You feed electricity into one of those. You feed it into the diaphragm, and the gap between the diaphragm and the backplate is so small that the electricity can jump across it and come back out the other side. As sound waves hit that flexible metal diaphragm, it moves closer to or farther away from the backplate. As it moves closer, the resistance between the two drops and more electricity can make the jump across. As it moves farther away, the distance between the two increases, the resistance increases, and less electricity can make the jump. So rather than generating electricity, it's modulating electricity. You measure the changes in the electric current coming back out of the microphone, and those changes are the result of the changing distance between the diaphragm and the backplate. Condenser microphones can be made very small, especially compared to ribbons or dynamics. They can be tiny. If you've ever had a gaming headset, it's probably a condenser microphone. If you have a pair of earbuds with a microphone that you use for hands-free talking into your cell phone, that's probably a condenser microphone as well. They can be small. They have a flat frequency response, so like a ribbon microphone, they hear equally well from the low frequencies to the high frequencies. They don't have a problem with anything along the way. And they have a very strong output level compared to the other types we've talked about so far. So what you'll find is if you plug a dynamic microphone into your camera and you set the levels and then you swap it out and you put a condenser microphone in, it's going to seem like you're blown away. The sound is going to be so much louder. You're going to have to turn everything down. The cons of a condenser microphone are that they also gather more noise. They're effectively more sensitive than the other types that we've talked about before. So this is why they have a higher output level, but that output level does include more noise. They also require electric power in order to work. Some of the microphones will allow you to insert a battery into them. Others will draw power from your recording equipment. Condenser microphones are well used for vocals. Again, they have a nice flat response, so they're good for almost anything, but they're particularly good for high-frequency loud instruments. Anything that's both loud and high-pitched, these are a much better choice than dynamics or ribbons because they handle it better. Dynamic microphones and condenser microphones are commonly used in the field. Ribbon microphones are commonly used inside studio environments because they're so fragile. There are other types of transducers out there, but the workhorses of the video field and the filmmaking field are these three. We talked about condenser microphones requiring electricity in order to operate. This electricity has a name, and that name is phantom power. It's called phantom power because if it's supplied to a piece of equipment that doesn't need it, such as a dynamic microphone, that piece of equipment simply ignores it as if it were a phantom. It's not even there. So sending phantom power into a dynamic microphone doesn't hurt anything, but it doesn't help anything either. It simply ignores it. Whereas phantom power has to be sent into a condenser microphone. Phantom power is typically 48 volts. Some microphones use a little bit less, but on any professional piece of equipment, you'll have the option to turn on a 48 volt power supply. You should only turn it on if you need it. Even though it's called phantom power, it actually can harm certain pieces of equipment. Phantom power can completely destroy a ribbon microphone, for example. And if you're plugged into another piece of equipment, for example, when I shoot at Mamiya Theater, I take a feed from the soundboard to capture all of the wireless microphones that they have on the actors. If I turn the phantom power on in that situation, I can actually damage the soundboard that's running all of the audio for the play. This is a photograph of the controls on our JVC cameras. You can see that there are 3 positions for input channel 1 and 3 positions for input channel 2. The upper one line, I would use that if I was attached to a piece of equipment. Again, if I was taking a feed from a soundboard, that would be a line level signal, not a mic level signal. The other 2 are both microphone signals, but one has the phantom power turned on and one does not. Any professional piece of recording gear will supply phantom power, and it will have a way to turn it on or off. In this case, it's a physical switch on the outside of the camera. If you're working with your camera at home, it may well be a menu option to turn phantom power on or off. And if you don't have the option, then probably your camera does not generate phantom power. One more concept we need to explore while we're talking about microphones is the idea of balanced audio. All professional audio equipment uses balanced audio. This is kind of a bizarre concept, but bear with me. Microphone cables, audio cables, are long antennas. That's just reality. When you have a long strand of wire lying about, it is an antenna. It absorbs radio frequencies. It absorbs noise. One of the things we do to combat that is called balanced audio. Now, RF noise, radio frequency noise, comes from a lot of places. Yes, it comes from radio stations, and sometimes it's as linear as that. You actually hear a radio station coming over a microphone cable. It can be other things as well. You can pick up static because somebody's running a microwave oven. You can get clicks in the audio feed because somebody's cell phone is close to the cable. The airwaves are full of radio frequency noises, and they all penetrate electronics. And in particular, they penetrate long stretches of cable. So balanced audio is a way to combat this. If you look at a typical microphone cable, there are 3 conductors inside. There are 2 typical wires, and then there's a third that's wrapped around them that's called a shield. This particular picture is of a nice expensive cable. The shield is made of braided copper. On cheaper cables, the shield could just be aluminum foil. All 3 of these are connected to both ends of the camera, but they're used for very different things. The shield stops a lot of RF noise. The RF noise gets picked up by the shield, but it doesn't penetrate it to make it to the 2 wires in the center, which is where the good sound is hiding. But not all of it gets stopped. So this is where the concept of balanced audio comes in. As we said earlier, the microphone is a transducer. It's changing sound wave mechanical energy into electrical energy and sending it out over a wire. But it's just a little more complicated than that. A professional microphone, balanced microphone, will actually take that signal and it will send it over 2 wires, the same signal over 2 different wires. So you have 2 different pathways that the signal is traveling. But on one of those pathways, it flips the phase of the signal. So the 2 signals are traveling down parallel conductors inside that cable, but they're out of phase with each other. And you remember from the earlier example, if we take 2 signals that are out of phase and we add them together, they cancel each other out. But we're not there yet. So as these signals are traveling over the wire, they're picking up RF noise. This is just reality. RF noise is going to penetrate our cable and it's going to mix with our signal. The noise is penetrating both cables at the same time, so it's getting added to both audio signals. But the noise is in phase with itself, right? If there's a peak in the noise on one cable, there's a peak in the noise on the other cable. The peaks and the troughs of the noise are in phase. They're in the same place. Here's where it gets fun. When we get back to the receiver or the recorder, that piece of equipment takes the 2 signals and it flips the phase of one of them so that now the 2 audio signals are back in phase with each other. But the noise, one channel has gotten flipped, so the noise is now out of phase with itself. So when these 2 signals are combined, the audio signal that we want is actually amplified because we have 2 in-phase signals being connected, and the noise cancels itself because the noise is out of phase with itself. How cool is that? That's pretty geeky cool if you ask me. Okay, takeaways from this. There are 2 different ways that microphones work, at least the ones we're likely to use in the field. They either generate electricity or they consume electricity. The ones that generate electricity are the dynamic microphone and the ribbon microphone. The one that consumes electricity is the condenser microphone. You should be familiar with the advantages and disadvantages of all 3 of those types of microphones. That's the sort of thing you'll see on a quiz. Understand that balanced audio exists, and it's not necessary to remember exactly how it works, but if you can remember that balanced audio uses phase cancellation to fight RF noise, that's pretty good. That about wraps it up for how microphones work. Next, we're going to talk about a concept called pickup patterns.